All right, hey, I'm going to kick this off. My name is Mark Tamalo. I'm the Director of Information Security at Cardinal Health. This is Jeff Graham, one of our senior architects in our analytics space. What we wanted to do before we kind of dug into it of lock it down or liberate it, just to give you a heads up, everyone on the team really wanted to liberate it. So sorry to ruin the last slide of the presentation, but we wanted to provide a little bit of context of where we're coming from. Some of this may not resonate at all with you, right? One size does not fit all, but we thought that it would be helpful to kind of give a little bit of background on the organization and the idea of the possibility of doing something versus the probability of doing something, especially from a security and risk perspective. That was big in some of our conversations. So just real quick, on any given day, Cardinal Health delivers to a give or take about 100,000 locations. Cardinal Health provides products, we provide services throughout the United States. About 85% of the hospitals use our products, our services. We're about $100 billion, give or take, puts us right at the 19 on the Fortune list. For an organization that does that much revenue, we're actually fairly small. 33,000 employees is not that much. I've seen some of the people that are out here and at this conference. If you bring in some of our contractual workforce, our variable workforce, that might take it up to 50 or so. But the type of data that we work with, it's very similar to what you all utilize, how you utilize, what you want to gain, how you want to gain insights from it. But what is a little bit different, probably to every one of our organizations, is the risk appetite for our lines of business. I'm not going to go over every single one of them, but on one hand, we have 50 nuclear facilities. On any given day, they manufacture nuclear medicine. If I walk in there, shoot a couple people, and know what I'm doing, I might be able to manufacture something else. That nuclear medicine goes to some pharmacies. You can't really manufacture anything, but it's got some nuclear waste. So the systems that support those environments, high integrity, highly regulated. So that risk appetite is very different than, say, our commercial group. They develop software, they sell software, they want to get that done, they want to get it to market, and they want it out the door, right? Corporate espionage is something that those guys deal with from a risk perspective. Code quality, right? A little bit different than what we just talked about. A third kind of use case that we always talk about is just kind of the greater Cardinal Health, where Cardinal grew up: distribution, logistics, trucks moving back and forth, manufacturing. I say this because those three risk appetites are very different, and sometimes those systems are connected, attached on the back end. Sometimes they're not. We want to make sure that those access controls are tight, and certain people, certain groups can access information, certain groups can't. So again, one size doesn't fit all. What Jeff and I are hoping today is that you can take a little bit from one slide, another bit from another slide, and if you can use that in your organization, that's a win. That's a win for this presentation. It's a win for the technology, and then obviously as we deploy and enable our businesses, that's key. So our challenge at Cardinal, we're not going to go over the benefits of big data. We get that. But securing those assets was a large concern. Assets for this conversation, just real quick, is a classification of data we call private. In that private bucket is generally anything that externally would cause us harm, right? It's HIPAA data if it got out. HIPAA data, PCI, FDA, DEA, you can throw SOX and stuff in there. So how that data was propagating through the organization, when I take it and move it, it's just doubling. If we bring in backups and the whole lifecycle management could be tripling, could be quadrupling. Our executives were not excited about that, and they felt like we needed to do something about it. From a security and risk perspective, what we were really worried about was the access controls around that. Who had access to it, who didn't. And then down the road, as we were building this, down the road, some of those use cases from how do we bring that data or the insights back from a referential integrity perspective, from a standard formatting, format saving perspective, as we look at the insights that we can dive into from a data perspective. Sorry. The key thing that we want to hit on is the whole team that was involved. And we'll go over a lot of groups that you probably need to get some buy-in from, is that risk and security and how we're going to protect this data was in the conversation from day one, and that in and of itself is a huge win as we deploy technology and some solutions. So Jeff and I are just going to toggle back and forth, and we'll obviously have some time for some questions after.
Okay, thanks, Mark. So yeah, again, I'm Jeff Graham, and I'm very loud, I guess. Okay, so like Mark was talking about, we knew we needed to bring Hadoop in we were reaching a lot of the big data hurdles that a lot of companies were doing with traditional databases. And what we found out early, and we started this about two and a half years ago, was we needed to balance the goals of the analytics group with the responsibility of governance and security. So like Mark said, we wanted to start out on the right foot, so bringing all these groups in was very important to get started. So basically we need to strike a balance here between protecting our data, all the data elements that Mark was talking about, and then also liberating our analytics community. So I'm a data guy. I like data. I like to work with it. I don't want to be hindered in working with the data, but we also have a responsibility to keep it safe. So there's that constant balance of lockdown and liberate, and really this emerged into two guiding principles that we're still evolving every day. We're still trying new things, and the first is locking down the platform and then liberating the data to authorized users, and not only giving them data, but keeping track of what data that they've accessed. So, and for me, everybody knows what liberating data, we want to make it available. And to be honest, at first, I was kind of against locking down the data, and an analogy came out that was really good. Locking down the data, we should embrace it as data analysts. We want to look at that as kind of like brakes on your car. While the brakes help you to slow down, you can kind of look at that as, that's slowing me down. It actually makes you more nimble, more agile. I can slow down going in that turn. I know those brakes will work. I know it'll help control my car. So having certain parts of your infrastructure locked down actually kind of helps me out a little bit. I can take more risks. If you look at a race car, some that are going through tracks with lots of turns, they actually have really big brakes, and that makes them more agile, faster through the track. So, like I said, we need involvement from many disciplines. We're going to kind of go through these 6 areas: platform security, identity management, network security, data segmentation, tokenization, and governance. So we're going to kind of hit on each one of these things and talk about how we lock things down or liberated them. So the first thing on platform security, we did a lockdown on a couple areas. With Jeff Battisti's help and Chris Embry, when we were creating this cluster, this was kind of new to us. It's really different technology. We're used to really large servers, really expensive servers, and we had to kind of take a different mindset with Hadoop. Hey, now we have tens, hundreds, maybe even thousands later on, these servers. How do we handle them? So like a lot of people, we looked at things like host-based firewalls on our control and data nodes. So we locked those down in different regions. A control node is what we would consider like the job tracker, the name node. And we blocked those off and segmented them. I'll show them here in a little bit from our data nodes. So we blocked those connections from unauthorized hosts. So even within our data center, we kind of had a perimeter security around our Hadoop cluster. Another really great thing that came about of this is the gold image boot for the data nodes. We leveraged technology to actually let us boot our data node images into memory and run off of that. That really helped us out because we didn't have to persist in OS. If we bring a system down, we can bring it right back up, and when that actual data node starts up, It says, okay, I'm here, what do you want me to be? If it's a data node, it goes and grabs the gold image, loads it up in the OS, and is off to the races. So it really helped us out on security patching. It also helped us out on feature patching. When we got into our advanced analytics and wanted to bring in R, it was relatively simple for us to have that gold image of a tested out R application actually running on the data node. And then what we were able to do, we could patch that into our existing cluster. So like I was saying, this was one of our very early drawings. Our clusters have grown since then. But what this does is from the left, or actually I'll move from the right. This kind of shows all of our data nodes when we first started out. They are separated from our control nodes through the host-based firewalls. And then those control nodes are separated from our access nodes. So access nodes can talk to control nodes, and control nodes can talk to data nodes. I do a lot of work with our clusters on a daily basis from a data standpoint. So I'm doing Hive, Pig. We're making sure new batch flows are going in, but I don't have access to our data node. I work in the access node area, so separating concerns was very helpful. So Mark, I'll give this over to you on identity management there.
Great, thanks.
Oops.
So I think, you heard Jeff talk a little bit about just kind of segmenting. We want to do the same thing from an access control perspective. And this isn't going to be rocket science to anyone here. The idea that users have access to canned queries, power users will have a little bit more access. They can do the queries, and we're going to give them a little bit more access to tools. Not more access to data, more access to tools to gather data that they should have. Same with the developers. The data owners, from our perspective, this is where we want the responsibility and that accountability for entitlements to reside. We'll touch on a little bit later, but the data owners within Cardinal, they take that data pretty seriously. We feel like that the conversations between data owners, they get pretty lively as to what someone else is going to do with their data as it starts moving around the organization. From a security and risk perspective, that's fantastic for us because it's helping the organization understand the benefit and the importance of that data. So you can see here that from an administrative perspective, Jeff kind of mentioned it, that he doesn't have access from an admin perspective. We know that admin crosses streams. Everyone over 35 understands the importance of not crossing streams, but from an administrative perspective, there's a trust level that you have to get comfortable with. Any security people in this room right now that you would say security? Okay, so there's just an inherent trust, and this is a conversation that is not specific to big data, to Hadoop, to any of those platforms. Malicious insider, stuff that they can do. It's a daily conversation, right? So I think I'm hitting on all that. Right? You guys can ask me questions if you need to. From a network security, I'm not going to drain this slide, right? This is for organizations. I would think that some of this stuff is table stakes to even have a company, right? Network security, perimeter security, it's pretty, it's a foregone conclusion. We're trying to layer security in there. You heard Jeff mention the gold image. You heard him mention the IP tables. What we're doing with Data Mirror, right? That's in the app layer, or the security node in, or security tools, the security functionality in Data Mirror, right? To break the IP tables, to break the VLAN, to thwart all of our governance and not be picked up by logging and monitoring as we look at our transactions, as we look at our events, and we look at our true security events, right? Could you do it? Of course you could do it. The probability of doing all of that and not getting seen, not getting caught, or not getting prosecuted, we feel like that's a good balance. So when we talk about do we feel comfortable with it, we feel pretty comfortable with it right now. From what we've heard with Hadoop 2, Hadoop 2.1, everything that's going on with some of the acquisitions that we've heard about over the past 30 days, that's fantastic, right? We knew that technology, we knew that the ecosystem would start to accelerate, and so if it's not all vaporware, then we'll be in a better spot in the next 6 to 12 to 18 months as well.
So let's talk a little bit about the other area that we had here. So one of the things that we found that we needed to do to liberate our data is how we work with our data on a daily basis. So data segmentation, in a way this is actually liberating the data by how we process it. There's some rules that it was kind of hard-won rules. It took us, there wasn't a book at the time that said process your data this way for all instances. But what we found is this was very helpful for us. So data is ingested under source-specific accounts. So, and keeping the ingestion loosely coupled with the transformation, we found that was really important. I'll kind of show you that in a little bit. And then also, what this really developed into is since they're loosely coupled, we had to be really concerned about having patterns that avoid having partial data products. So atomicity was very important to us on how we ingested the data. So what happened with this is, since you can see here on our different ingestion here, the ingestion coming through, since it's atomic, we can guarantee it to be atomic. We can separate that from our transformation and then apply security at those different layers. So I have source system security. I also have transformation security. And by the way, this is really great. Like Mark said, as we're learning about the new features that are coming out and the new stacks, ACLs. When I was looking at that, it's like this is gonna feed in really well to the way that we're doing this. So I'm going to kind of go into a little bit on the technical side on ingestion. So along with the atomicity, we had to make sure that we landed our data in an all-or-nothing approach. If a load fails, we didn't want to see partial streams because, as you know, as those gears are turning, if we have partial streams or transformations, then we'll be suspect. You'll have problems with your data there. So here's just an example. This is one of our frameworks for how we ingest data from a relational database. A lot of people that have been doing this for a long time will probably say, hey, okay, that's apparent. But I wanted to bring this up here. If you're new into Hadoop and trying to figure out what your patterns and practices should be like, it took us a while to get to this, and maybe this will help jumpstart you a little bit. So from the left, one of the things we did from relational database, use Scoop. Everybody knows about Scoop. We'd actually stage all those part files into a landing area, into HDFS. After those were all landed, Scoop processed fine. We got a good return code. We knew the number of records. Then we'd actually do a copy merge. We'd use that function in the API. If you're doing several mappers, if you had 10 files, we really wanted to merge those into one file to make it easy for us to manage. So that's where that copy merge API came in. Again, that happens after Scoop was successful. Once it's merged, we rename it, and it's just a naming standard for us to keep track of files. It really helps out. That merging helps having one file helps on our maintenance side tremendously, bringing in all those part files. And then the final step here, the way that we maintain atomicity is just doing the move. So when the move happens in step 3, it's going to move it from the merge and rename area out to the target area, the source area where we keep the data. So that whole process we have automated with tooling, but that's really how it works under the covers. And so at the end of the day, we know that target area has a complete file. It's all there, or it's not there at all, and we have a problem, we can look into that. So it kind of looks like this. This gave us the flexibility to segment our ingestion privileges independent of any transformation. So, as you can see here, I'm bringing in clinical data. I'm ingesting market data, various market data elements, sales, logistics, whatever it is. Again, we're keeping those loosely coupled. So those gears are always turning in there, ingesting data. And then once I do that, I can start putting in my transformations in between, joining all my data sets together, getting value out of the ingestion and the transformation, and segmenting those for our data standpoint. So As you can see, we have outcome-based medicine, different transformations happening there, different insights, so on and so forth. So Mark, I'll give the tokenization
Jeff
over to you.
redid his slide just so he could use this pointer, and so I'm going to as well. Here is very important. Not so much here, here. There you go. So if you remember something that I mentioned kind of in the opening sentences, one of the reasons we were doing this is we were a little bit uncomfortable with the propagation of our private data throughout. So one of the kind of key functions that we wanted to get with this project was, if we can make data not private, I don't care about it anymore, unless our data owner cares about it, right? So one of the ways that we did that was from a tokenization perspective. And so not to bring you into the craziness of our legal and regulatory and vulnerability and cyber balance that we have to with regards to the data that we take in. The idea of private data, there are just things that are private data that nobody questions, right? So social security number, there's about 18 things from a HIPAA perspective that we have to do. From a PII perspective, identity. There are certain things that are just identity information, your name, your passport ID. And then there are some things that mean absolutely nothing unless they are coupled with that. We always call them plus ones, but it could be blood type, it could be age. There's a number of things. And so it's not as simple with what we were doing. It's not like credit cards where we can just separate it, tokenize it, and get it out of the environment, because especially from an analytics perspective, we need to bring that back together. And so it gets a little bit hairier. And so when we look at those private attributes, or we look at some of the case studies from an analytics of what we're doing of, how do I take this analysis of data and I can infer back to age, demographics in this geography, and yes, we now know that Mark Tomalo has cancer. Doctor, you need to go tell Mark that he has cancer because we have done that. How do we de-anonymize that? That's a challenge, because from a statistical opinion perspective, and anyone who's dealt with HIPAA or EPHA or Health and Human Services of what that definition is, it's fairly gray. And so that's why you see an asterisk up there, but it's the idea of anonymizing, tokenizing, encrypting is some of the easier things that we can do. De-anonymizing and getting back to some of those use cases or some of those requirements that our business needs, especially around the analytics on what they're doing with the data. Those are some lively conversations of, are you allowed to do it legally? Do we have the paperwork in place? From a data ownership perspective, is this data owner going to allow you to do this? And then do we have some of those controls in place that we've already talked about? And so if you kind of, not that you're keeping track, but we're going to talk a little bit about governance, but we've got governance, or we're going to talk about governance. We've got segregation. We've got segmentation. We've got logging and monitoring. The idea of that defense in depth of, is this good enough in our 4 walls or 8 walls that we feel comfortable with? Where we are right now in our program, we felt comfortable with that. Do we still have to protect against side channel attacks? Yes. Do we worry about the endpoints getting compromised and malware and Trojans? Yes. Do we worry about harvesting of credentials? Yes. But that's not inherent to the Hadoop platform. It's not inherent to big data. That is an issue that we all face, and every security and risk team faces that. So I think I mentioned referential integrity and format preservation, right? Yeah. All right. So we tokenize some data, And we decided not to tokenize in Hadoop. We tokenized before it got to our cluster. And so we feel like that's a good model for us. In some of our business units, we may actually have a different architecture with that. But contextual tokenization, complete tokenization, contextual encryption, complete encryption, we are looking at everything from a do not move this data, to get rid of this data, to mask this data. Sometimes that's a challenge when we need to have format preservation. Tokenize this data, encrypt this data, right? So we are trying to offer our lines of business and our data owners a number of different options. And kind of what you're seeing is when they make that decision to do analytics, to move to Hadoop, we have some options for them.
I think we'll talk about tokenization here a little bit.
Do it.
Okay. Am I on?
No.
Nope.
That was Jeff's polite way of saying, Mark, you forgot something on tokenization.
Sorry about that. So tokenization, yeah, one of the, like Mark said, this is one of the areas that we kind of had to liberate our analysts to be able to use things, use the data with less risk, especially your PHI data. So as you can see here, the Gateway gave us a centralized reusable framework for transforming this private data. Just a real simple example, again, to use with a pointer. You have your address over here to 1313 Mockingbird Lane, gets thrown into this anonymized string. So, and so on and so forth. So the Gateway, like Mark said, it's outside of our Hadoop cluster. The way we architected it, we wanted to have a highly protected service outside of the cluster to give us the most flexibility and working with other pieces in our enterprise. This is an ongoing effort, but we started out with this piece right here. So our Tokenization Gateway started out as just batch processing. So again, you'd have a source database out here to the right, real simple at a 50,000 foot level. It got dropped into the gateway. The gateway would handle the keys and drop them into a vault, and then we would send those results onto Hadoop. The nice thing about this, when we started with batch, we also could include things for streaming APIs, web service message broker agents. So that flexibility, that afforded us kind of the flexibility in our comfort zone to work with this tokenization. As we evolve, things could change in the architecture on that. So a little bit deeper inside, the gateway is really composed of 3 different areas. At the top there, when the data is dropping in, we have a private area. It's the data that needs to be tokenized. At a minimum, it must be comprised of the primary key and the token values. And some data sets, we just drop the whole thing in. It's a multi-tenant store with role-based security, so we can have many different users using this gateway. Once the data is dropped in the private area, the gateway picks it up and processes those keys into the vault. We store that private data in the SHA-2 128-bit AES encryption. We kind of have a special way that we were able to generate the tokens and preserve the type, which is really important to us. The tokens are sharded and referenced by name so we can share them. And the access is extremely limited. It's only the admin that has access to this vault. No one else has it. Then what happens once those keys are processed in the vault, out comes the data onto the public side. Again, this is a multi-tenant store, so if you drop data up in the private, call for the tokenization, you'll get your data only on the public side, only in your area. The tokens are generated, they're dropped in the public region. The private data may read public, but public may only read public. So keeping that multi-tenancy is really important for us. We want to make it a tool that we could use across the enterprise. So Mark?
Whenever you can take a word like sharded, use it in a business context, put it in a PowerPoint, you're going to get security and risk support on that. So I just needed to call that out real quick. So I guess we're going to end on a lessons learned slide, but I guess in summary, the first thing is have the right players at the table. In our organization, that looked like Jeff's team, so the Hadoop technical team, the architecture team, the analytics team, the legal team, the security team, the risk team, the data owners. Most of the custodians in our organization reside somewhere within an IT function, but kind of the custodians and the stewards, not the splice and dice definitions, but having those technical controls in place, or at least using what's at our disposal for this first go-around. We're not winning any awards for blazing trails, right? We got Pixie Boot, we got Gold Image, we got IP to IP protection, we've got access controls, right? This is doing more with less and having the business input to say, here are the risks that we're willing to take, and then everyone moving forward together. And that is important. Jeff did an amazing job from a technical perspective. Jeff and a couple other people on the team. The technical aspect of where we're moving is going really well. There's typical challenges that we deal with, but what was really key was we really went into this like, hey, how are we going to deploy this? We got to be pretty tight on our messaging. We got to understand what the requirements are. We need to knock this out of the park. The feedback from the business really, where we got most of our kudos was because we uncovered some real challenges, and I think this is probably across enterprises as we speak to companies. The governance, privacy, and when I say privacy, I'm lumping in kind of the legal and legalities in there. And that declassification of that data were our largest challenges. Understanding the data ownership, as I said, we feel like we have a pretty good understanding on that. Every once in a while something pops up where no one knows who owns this data, so we got to go hunting people down. But from an organizational perspective, Peter and Drew yesterday did a great job talking the Booz Allen guys. They gave a pretty good case study on where the CISO had said, I am not comfortable with some of this information being combined. The accountability across organizations, it's a challenge. I'm not sure I'm 100% in agreement that the CISO should own that decision. However, in our organization, it won't be in our upline. So I think that accountability as you look to, as we are taking data, as we have statistical opinions on a certain data set, yet we are mixing and matching, and now we are in uncharted territory because we're creating data. That's tough to overcome right now for us, and so we're on our way. I mentioned something about statistical anonymization, sorry, not anonymity. I'm not even going to finish it. We haven't achieved pure statistical anonymization yet, and we're not going to try. That's not our core competency. We'll pay the math geeks at the colleges to say, yes, this is correct. The legacy and source metadata classification is a challenge for us. How we classify that, how we find it, how we label it, that entire token life cycle is incredibly complex, and I'm going to end with that of the complexity of a mature tokenization solution really is kind of orders of magnitude more complex than, I don't want to say than we thought, but if you extrapolate it out to year 2, to year 3, to year 4, we knew this tokenization was probably going to be a Band-Aid, but we got to that Band-Aid, or we got to the end game a little bit faster than what we thought, because the margin of error, the penalty of error for us to either re-tokenize, that's a showstopper for us, or to have something different happen, like a breach, HIPAA breach, or State's Attorney General, PII, getting out, it's not worth it to us. So that really came to the forefront very quickly. And then that metadata piece, since we have not gone through a full life cycle from a metadata perspective, of data life cycle, data that has retention of 7 years, data that has retention of 20 years, when does data become a liability from us, right? Whether it's the storage, whether it's the operations, whether it's the breach. I think some of the scientists call it the marginal utility of that data, right? And so those are just kind of some of the things that we're going through with regards to our lessons learned, and as we mature through this, kind of keeping some of those things definitely in the rearview mirror, but addressing them as we move forward. So if I forgot anything, you let me know, but we've got about 3 minutes for questions. Grab Jeff and I afterwards. I see one question back there.
Thanks for the interesting talk. The tokenization is an interesting solution. In terms of liberating the data, I'm trying to visualize how one would answer the question of, for instance, graphing frequency of prescription usage as a function of neighborhood across a city. Are you able to do that without beating the token server to death?
Yeah, so the nice part is we're bringing the data. That's why we placed it in front of Hadoop for a bunch of different reasons. But one of the big ones is we can tokenize that data and land it in Hadoop and then process on that anonymized data. So it's already anonymized. We can also tokenize it going in. If we find out something that's really important that we need to get back to the original value, it's sort of like a heat pump. It cools, it heats. You can reverse the flow if we need to. So in those instances where a data scientist might find something that's very important and we can get the security clearance to get the sign-offs for it, we can reverse that flow back and find out what those keys were, get back to the originality. And that's one of the things why we're really concerned about being able to tokenize it in, have it encrypted, have it safe, but also be able to return it back to its original data value with as much fidelity as we can. So when it's returning back, we knew what original data type it was. We can return that back. It's actually kind of a outlier a little bit. Most of the time, we're working with the data. They don't need to know that PHI proportion of that data. They might need to aggregate some other values that aren't appropriate to that particular data set. But in those rare cases where they need to go back, we have that capability. Did that answer your question?
So my question was related to carburization. Do you have carburization in place? And if you do, then how do you let users access the job tracker and task tracker from your access layer?
I'm sorry, can you repeat that?
Do you have carburization in your cluster? Is your cluster
Are you
carburized?
saying carburization?
Is
No.
Kerberos?
Yeah, no.
Okay.
Thanks. Sorry.
Hi there. Question. How do you handle data at rest encryption? Are you using self-encrypting drives, or are you doing it in software?
That's our next phase.
Okay.
That's where we're going to. So right now, we're looking at those options. We're really excited. We're upgrading to, Yarn. Like Mark said, all the different vendors that are bringing in the security components, we're looking at those closely. We know that's where we need to be. That's one of the reasons why we were working on the tokenization part before, because we realized those inadequacies in the security area that we currently have. So we did not want to take that on inside the Hadoop cluster yet. Like Mark said, we learned a lot off of it. We learned a lot, so that really was a nice ramp into the new feature set that we're going to see with Yarn.
Thank you.
I think this will be the last one.
So I was just curious about audit logging for whenever people are doing searches or queries, analytics or whatever against the data that's in the cluster, you may have the requirement to audit those accesses. Is that all handled at the outermost layer on those access servers? So it's not dealt with within the cluster at all, or what?
Yeah, right now it's on those outer layers. I'm really excited about Nox and what that's going to bring for us. One of the tools that we had in one of the slides we use a lot for our data discovery is Data Mirror. And one thing that was really neat with that is we started analyzing the logs that were coming off of Data Mirror, and twofold. One was to be able to audit who's looking at what and that whole security layer there. And then a really good side benefit was we can see which data sets are being used the most. So we started doing use analytics on our data. So it's a little bit of inception, right? We're actually turning Data Mirror on itself and using the logs out of Data Mirror to see who's looking at what. And that's worked out well. But on our list is, the things that are coming through Nox and a more complete internal cluster approach to auditing.
Thank you.
Hey, thanks everybody. Have a good rest of the conference.